Here I have a short ruler about 16 centimeters long and a meter stick 1 meter long. We're going to let this ruler fall to the platform here. Okay, it starts out slowly. Whoops, fell the wrong way there. I'm keeping my thumb here because otherwise the ruler might slide back a little bit. So I'm keeping my thumb there to constrain the ruler so that it rotates about a fixed point down near its end. Okay, so we see that the ruler falls over. No big surprise there. Now I'm going to move over just a little bit here. If I drop or allow the meter stick to fall in the same way, okay, it also has a similar behavior. Which one's going to fall fastest? Faster. You have to have at least 3 of them before you talk about fastest. Let's see. Let's release them both. Gee, it looks like they fall at about the same rate. They stayed right together. I wonder why that is. Whoops. They don't stay together very well if you happen to bump one of them. So I got these here and managed to release them simultaneously. They seem to stay together pretty well. Let's think about what's happening. As the meter stick falls, it acts as if all its weight is centered at its center of mass, right here. So, you can't see the whole meter stick, but it's falling about this point. As it falls, it's acting as if its weight was acting downward at this point. Now, when that happens, of course, since we're constraining the meter stick to rotate about this point here, that weight exerts a torque on the meter stick. And that torque accelerates the meter stick. Now remember, the meter stick is a uniform beam, essentially, uniform rod or beam. It has a moment of inertia when constrained to rotate about this endpoint of 1/2 ml squared. Whatever its 1/2 of whatever its mass is times the square of its 1 meter length. It turns out that the mass of this meter stick, we weighed a typical meter stick and found out that it's about a Newton. So the mass turns out to be around 1/10 of a kilogram. So we've got a moment of inertia about 1/10 of a kilogram meter squared here. In any case, what we want to do is analyze the acceleration of this meter stick under the influence of this force. Another thing that we want to notice, now, didn't talk about it over here with this example, but let's look at this example again. When I was rotating the meter stick with the force at an angle, I had to constrain this end by holding my finger there. If I didn't, the meter stick would simply slide away. So I'm having to exert a force. And the lower I bring the weight, the balance, the more force I have to exert, and the more force I feel on my finger here. If I didn't constrain the meter stick as it falls, it would slide. It started sliding right about this angle. It just started sliding backwards along the board here. And we want to look at all these behaviors and maybe analyze them to some extent.